Do not forget, you can support the channel with a like, and you can also subscribe to be aware of the latest published videos. Thank you. We hope that here you can find the latest news, ideas, and discoveries from the scientific world.
Bones like Aero chocolate, the evolution adaptation that helped dinosaurs to fly. It's sometimes difficult to imagine how the planet we call home, with its megalopolis cities and serene farmlands, was once dominated by dinosaurs as big as buses and five-story buildings. But recent research has helped deepen our understanding of why dinosaurs prevailed. The answer may lie in their special bones, structured like Aero chocolate. Brazilian paleontologist Tito Orellano found that hollow bones filled with little air sacs were so important to dinosaur survival. They evolved independently several times in different lineages. According to the study, aerated bones evolved in 3 separate lineages: pterosaurs, technically flying reptiles, and 2 dinosaur lineages, theropods and sauropodomorphs. The researchers focused on the late Triassic period, roughly 233 million years ago, in South Brazil. Every time an animal reproduces, evolution throws up random variants in genetic code. Some of these variants are passed on to offspring and develop over time. Charles Darwin believed evolution created endless forms most beautiful. But some adaptations emerge spontaneously time and time again, a bit like getting the same hand of cards on multiple occasions. When the same hand keeps cropping up, it's a sign that evolution has hit upon an important and effective solution. The variant the Brazilian team studied was aerated vertebrae bones, which would have enhanced the dinosaur's strength and reduced their body weight. Light but mighty. Your regular deliveries from Amazon or other online retailers come packed in corrugated cardboard, which has the same advantages as aerated bones. It is light, yet tough. Corrugated cardboard, or as it was first known, pleated paper, was a man-made design experiment that was hugely successful and is now part of our everyday lives. It was patented in England in 1856 and was initially designed to support top hats, which were popular in Victorian England and the US at the time. 3 years later, Darwin published his On the Origin of Species, which outlined how evolutionary traits that create advantages are more likely to be passed on to future generations than variants which don't. CT scan technology allowed Orellano and his colleagues to peer inside the rock-hard fossils they studied. Without the modern technology, it would have been impossible to look inside the fossils and detect the air sacs in the spinal columns. The study found no common ancestor had this trait. All 3 groups must have developed air sacs independently, and each time in slightly different ways. The air sacs probably enhanced oxygen levels in the dinosaur's blood. The Triassic period had a scorching hot and dry climate, so more oxygen circulating in the blood would cool dinosaur bodies more efficiently. It would also allow them to move faster. The air sacs would have buttressed and reinforced the internal structure of the dinosaur's bones while creating a greater surface area of attachments for large, powerful muscles. This would have enabled the bones to grow to a far larger size without weighing the animal down. In living birds, aerated bones reduce overall mass and volume, while enhancing bone strength and stiffness, essential features for flight. Paleontology not only tells the story of what might have been for Earth had it not been for that infamous asteroid, but also helps us learn about the evolution of still living creatures. Prehistoric connections. Echoes of this dinosaur legacy lie in many animals alive today. It is not only long-dead animals which found this type of adaptation useful. Many bird species living today rely on hollow bones to fly. Others animals use the air sacs to buttress and strengthen their large bones and skulls without weighing them down. An excellent example of this is the elephant skull. Inside elephant skulls are large air sacs which allow the animal to move its massive head and heavy tusks without straining the neck muscles. The human brain is also protected by 2 layers of hard, compact bone which sandwich a layer of softer, spongy and aerated bone in between, known as the diplo. This allows our skulls to be light, but strong and able to absorb shocks to cranium. These are examples of convergent evolution in which animals are faced repeatedly with the same problem, evolving similar, but not always identical, solutions each time. Animals today are playing by the same evolutionary playbook as the dinosaurs.